Good afternoon, everyone. I would like to welcome you all to the YouTube channel of Chem Academy. So today we are here for the Chem English session, and we are going to be discussing the previous year questions from the topic periodic properties. Good afternoon, Priya, Karan. Good afternoon, everyone. Arjun, M.Sc. Prapula, Sachin sir nahi le rahe hain ye class. I'm going to be taking today's session. Sona Tapaswini. Okay, I think everybody has joined. So I'm going to be starting with the questions for today. If you haven't subscribed to our channel yet, quickly go and subscribe to the channel. All right, quickly subscribe to the channel, like today's video, share it with your friends so that everyone can watch today's session and you all will be able to solve the questions together then. All right. Am I not clearly audible? I think I am. I just checked the volume. I am very much audible. If anybody is facing issues with the volume, kindly connect your headphones. The volume is absolutely okay. I would suggest you to connect your headphones if you are facing any issues with the volume. Okay, so I'm going to start with today's session now. We'll discuss the previous year questions, IIT JAM questions from the topic periodic properties. So here's the first question for today. This question says that among the following, the isoelectronic pair is. We have to determine the isoelectronic pair. As the name suggests, it is pretty clear what isoelectronic means. Isoelectronic means when two species have same number of electrons, then such species are known as isoelectronic. This is what isoelectronic means. So one by one, we will determine which of these are isoelectronic. So if I talk about NO and CO, all right, if I talk about NO and CO, the electrons in this is going to be 7 plus 8, 15, and in this are going to be 6 plus 8, 14, not isoelectronic. Again, now we will come to the option B, which is O2 minus and NO minus. So the number of electrons are going to be in single there are 8, in single O 8 is a 16, and this extra electron it means 17, and over here they're going to be 7 plus 8 plus another electron 16, therefore not isoelectronic. Now coming to the next option, if we have NO plus and CO, let us calculate the number of electrons. Again, 7 plus 8 plus, this is a plus sign, therefore 1 electron will be less. Therefore 7 plus 7, this will be 14 electrons. All right, and in this case, we have 6 plus 8. Again, here we have 14 electrons. Therefore, this is the isoelectronic species, and option C should be the correct answer. Yes, Ayushi, Dr. Arjun, Ram Prakash, Manoj, yes, all of you are correct. C option is going to be the correct answer. This should be pretty clear. It was an easy one. Neha, Amalia, sorry, I'm sorry if I mispronounced your name. Neha Amlia. All right, yes, C is the correct answer. Now moving on to the very next question. See, over here, okay, this is just the solution. You can go through it later when we upload the slides. This is the next question. Among lithium, nitrogen, carbon, and oxygen, which element has the highest first ionization potential? All right, first ionization potential. So for this, we will have to write down the electronic configuration of all of these. So for this, the electronic configuration is going to be 1s2, 2s1. All right. If I talk about nitrogen, it is going to be 1s2, 2s2, and 2p3. All right, 7. 1, 2, 3, 4, 5, 6, 7. For this, it is going to be carbon 1s2, 2s2, 2p2, all right. And for oxygen, it will be 1s2, 2s2, and 2p4. So we have to determine the highest value of the first ionization potential. Now over here, we know that nitrogen over here has half-filled configuration. This is not half-filled or fully filled. Neither is this half-filled or fully filled, and this is also not half-filled or fully filled. We know that in case of half and fully filled, we know that in case of half and fully filled configurations, the amount of energy that is required to take out an electron from the valence shell is the maximum. Therefore, the first ionization potential in case of nitrogen is going to be maximum. Okay, everybody is saying B, Ayushi, PK, Manoj, Sumitra, Ram Prakash. Yes, PK half-filled nitrogen, you're correct. MSD. Yes, Dr. Arjun, Neha, Sumitra, yes. Archana, no. How are you even saying lithium? It might have smaller size than nitrogen. No. Lithium is not going to be the correct answer. There is no way lithium can be the answer to this question. Now we will move on to the next question. Okay. Please like this video if you haven't done that already. See, look at this question. What does this question say? Identify the correct option in the periodic table on moving from left to right among a period. The following are the options. All right, I am giving you 30 seconds. Please tell me what should be the correct answer to this question. You have 30 seconds to answer this question. Let me know in the chat what according to you should be the correct answer for this question. I'm waiting for your answers. Please write according to you what should be the correct answer to this question. Okay. So everybody's commenting. PK says C, Tapaswini A. Okay. So most of the people are saying C. Mehnaz, Manoj, Aryan, Puneet, Golu, Sumitra, Archana. Yes. So let's see. We will go one by one as per the options, and then we're going to figure out what should be the correct answer to this. Here it says on moving from left to right among a period, the atomic size of the element increase. This statement is absolutely incorrect. When we go from left to right, in a period, the Z effective increases. All right, the Z effective, this is the effective nuclear charge or the effective atomic charge. This increases. Therefore, the atomic size of the element decreases. So the first statement is absolutely incorrect. The first ionization potential of the element decreases. This is also, when we go from left to right, since Z effective increases, the ionization energy or ionization potential also increases. All right. This is also going to increase. So the statement is also incorrect. When size is going to decrease, the ionization potential is going to increase. So it will not decrease here. Now coming to the C part, the oxide of the element becomes less basic. Yes, this statement is absolutely correct. So the elements which lie towards the left, of the periodic table, they are usually basic in nature. And as we move from left to right, the basicity decreases and their acidic nature increases. All right, the oxides of elements become less basic as we move from left to right in a periodic table, and their acidic character is what that's actually increased. Okay. Yes, Mehnaz, PK, you're correct. Yes, acidic nature of oxide is going to increase and the basic character is going to decrease. Okay, I think everybody got it. Now I'm going to proceed to the next question. See, this is the next question. The decreasing order of the first ionization energy of the following element is. Again, we are going to go by writing down the electronic configurations of each of them. Let us first write down the electronic configuration for He. It is going to be 1s2. Then for hydrogen, it is going to be 1s1. For beryllium, it is going to be 1s2, 2s2. And for boron, it is going to be 1s2, 2s2, and 2p1. All right. This is for helium, hydrogen, beryllium, and boron. I have written as per this series. This is in no particular order. All right. This is not in order. So, if I have to check the first ionization energy of the following, see, this is fully filled. This is the fully filled noble gas configuration. This is fully filled here. So this is actually in the noble gas configuration. You will say, no, this is also fully filled, but the size of He is actually very small. The size of He is actually smaller. Okay. So the ionization energy of He is going to be the highest. Then hydrogen, it is also very small in size. It will have very huge amount of ionization, first ionization energy. So this is going to come at second. And then out of these, since again this has a fully filled configuration, so this will come at third place. And boron, it will easily lose this electron to attain a noble gas configuration. So this is going to come at the fourth place. Okay, so this itself is going to be the answer. This is going to be the answer to this question. आर्यन उपाध्याय मैम IIT जैम के लाइव केमिस्ट्री बैच 2022 में बेस से ही स्टार्ट करेंगे क्या, प्लीज टेल मी. Aryan Upadhyay, if you're talking about the batch that is going to happen on the Chem Academy app, then yes, you will be taught everything from the very basics, and all of your concepts will be clarified from the fundamentals. Okay, there is absolutely nothing that you need to worry about in that. You should 100% join the batch, and all of your concepts will be clarified from the very basics. The new batch is going to be starting in the first week of June itself. So you can enroll, you can call on the office number and you can get enrolled in the batch. Okay, so Aryan, PK, Sumitra, Ayushi, Sumitra, Ramprakash, Sandhya, okay, everyone is saying A, yes, everybody got it. Mehnaz, is this important for NET gate also? Mehnaz, the questions that come in IIT JAM are the fundamentals. They are the basic. They're the kind of questions which form the basis for NET and GATE. So if you cannot do the questions which are of the JAM level, then it will be very difficult for you to be able to crack NET and GATE. All right. So it will be beneficial for you if you do these questions. There is no way it is going to harm you. मनोज मैम लेफ्ट टू राइट साइज डिक्रीजेस ना, बी का ज्यादा नहीं हो सकता है क्या? Manoj, it is not about the size here. See, here beryllium actually has fully filled shell, right? So it will have higher ionization potential because when it has a fully filled shell, then it will be difficult to take out an electron from this, right? So this will have higher first value of ionization potential, whereas in case of boron, we can easily take out this electron because after the removal of this electron, it is then going to attain a fully filled configuration. I hope you've understood what I'm trying to say. Ashwin Sriram, ma'am, when Chem English classes will start? Ashwin, Chem English classes, they happen every day. They actually happen every day on the Chem Academy's YouTube channel. Every day you can attend the Chem English classes from 1 p.m. to 2 p.m. All right. I have been taking the Chem English classes for a while now. You can go and check out the other lectures. They are already present on the channel. You can search for the Chem English classes. There are also other teachers who've taken Chem English classes, and you will be able to find all of those on the channel itself. And every day you can join in and watch the lectures with us. Cost of Bohr by ionization of H is higher than that of Be. Because of the size, you see, hydrogen, it has only this one electron. This has just this one electron. So all the nuclear charge is on this one electron that hydrogen has. Can you imagine how difficult it is for it to lose this one electron also? Yeah, beryllium is slightly bigger in size than hydrogen, right? So it will comparatively give this electron more easily, but the size of hydrogen is extremely small. So when the size of an element is very small, it is very difficult to pull an electron out of it. I think you understood this. Now I'm going to move on to the next question. Now, the degree of hydration is expected to be maximum for. So before I tell you the answer to this, see how do we do it? The degree of hydration, or I'll say the hydration energy. See, degree of hydration is directly proportional to the charge density. Okay, it is directly proportional to the charge density. So it is directly proportional to charge. Hydration, degree of hydration is directly proportional to charge, and it is inversely proportional to the size of the element. All right. So in this case, so since it is directly proportional to charge, so more the charge, more will be the hydration energy. Okay, more will be the degree of hydration. So see which of these has the maximum charge. Here the charge is +2, here the charge is +1, here the charge is +2, and here it is -1. So this and this have the maximum charge. Now we will compare their size. This is not going to be the answer. This is not going to be the answer. We've compared their charges. Now we will compare their size. So both of these, they belong to the second group of the periodic table. Let's see what their size is going to be. Beryllium, magnesium, calcium, strontium, and barium. See, this is magnesium here. This is barium. So this will have more size. We know that size is inversely proportional. See, size is inversely proportional to degree of hydration. So it will have more size, therefore it will have less degree of hydration. So the correct answer is going to be A. The size of Mg is smaller than that. Mg+2 is smaller than that of Ba+2, and they both have equal charge. So on the basis of size, it is inversely proportional. Size which is inversely proportional to the degree of hydration, we can know the degree of hydration is going to be maximum for Mg+2. Oh, okay. The fourth option is not visible. I will write it over here. The fourth option is K negative. This was the fourth option. Okay. I just realized that the fourth option wasn't visible to you all. So this over here is the fourth option, which is K negative. Okay, so that's how we do questions like these based on the degree of hydration. Yes, A is the correct answer. Mehnaz, yes, Mg, small size, high charge, correct. Manoj, yes. Now moving on to the next question. Now see, here in this question it says, this question says that the decreasing order of the first ionization energy of the following elements is. Again we are going to write down. So okay, so before I tell you the answer to this question, there is one thing that you should memorize which is very, very important. Okay, so arsenic, beryllium and antimony. Just memorize this. There is no logical explanation for this. Okay, this is the order of the ionization energy. These three you have to remember. This could be asked in any of the exams. This is arsenic. The ionization energy of arsenic is more than that of beryllium, and that of beryllium is more than that of antimony. Just memorize. I'm writing here. You will have to memorize, cram, learn, whatever you want to say. But you should do this. Just memorize this. Okay. And this order will remain unchanged. Okay. Now, if I talk about the question here in particular, let's see. The first order of ionization energy, Xc is common in all. Okay, so first of all, it's going to be Xc. All right. Out of arsenic and beryllium, I've already told you that you need to memorize this. So it is going to be arsenic then. Okay. Then it is going to be beryllium. And lastly, aluminium. Since, see, the configuration for aluminium is what? 1s2, 2s2, 2p6 and 3s2, 3p1. So it will be easy for it to lose the electron. So this is going to be the answer over here. All right, see, this is the correct answer. All right, C option is going to be the correct answer. Oh, okay. All of those who have written, I see there has been a lot of confusion in this particular question. A lot of you have given the wrong answers to this question. Manoj said D, Munna said D, Shailesh D, Piku D, Shailesh again. A lot of you have said that D should be the correct answer. No, no, no. The answer is going to be C. See, once again, I'm going to tell you that there is no logical explanation. So see, when we study periodic properties and when we study the characteristics of various elements in the periodic properties under in the periodic table under the chapter periodic properties, there are a lot of exceptions. There are like a lot of exceptions which is impossible for us to memorize, but yet we have to do it. And there is not a logical explanation for every exception out there. So this is one such exception. Okay, there is no logical explanation for this, but this is something very, very important. And I will request you to memorize this because questions do come from here. And this is something that you need to remember. And on the basis of this, we have solved this particular question. This is one order where you could be asked questions from. So the correct answer is going to be C. We know that Xc has a noble gas configuration, so it will have the highest first ionization energy. Then from this order, we know that that of arsenic is going to be more than that of beryllium. And aluminium is obviously going to come in the end because it has the last electron in the 3p1 and it can lose this electron very easily. So it will not have a very high value of the ionization energy. I think everybody got it. Please like this video. I see a lot of you are watching with me live now. We are all solving the questions live. Please, first of all, like today's video and only then we are going to proceed to the next question. Quickly like today's video. Subscribe to the channel if you haven't done that already. Quickly like the video, share it with your friends. फटाफट लाइक कर दो, उसके बाद ही मैं नेक्स्ट क्वेश्चन में प्रोसीड करूंगी. Follow me, Ghosh. I have just explained the reason. I have just explained the reason why option C is going to be correct. I think you missed it. If you have missed it, you can watch the lecture once it gets over, and you will be able to find out the correct explanation. All right, I have already explained this question. Please watch the lecture again. So this question is done. Now we will move on to the next question for today. Okay, so this question says, with respect to periodic properties, the correct statement is. So here we will check each of these statements one by one. All right, we will check the following statements. Now, what is electron affinity? Electron affinity क्या होती है? So electron affinity is actually the amount of energy that is involved. The amount of energy that is involved in adding one electron, in adding an electron in an isolated gaseous atom. ठीक है? So electron affinity is actually the amount of energy that is involved in adding an electron in an isolated gaseous atom. Also one important thing is that electron affinity is actually equal to, see, electron affinity is equals to the negative of electron gain enthalpy plus 5/2 RT. This is something extra that I am telling you. Electron affinity is actually equal to the negative of electron gain enthalpy. And if I talk about at room temperature, electron affinity is going to be equal to the negative of electron gain enthalpy. Okay, this is something extra which was related to electron affinity and electron gain enthalpy. Now, over here, let's see. So first of all, it says that the electron affinity order is F, then O, then Cl. This is absolutely incorrect because the size of F is actually very small. The size of F is very small. Therefore, there will occur repulsions. All right, so if it gains an electron, then there are going to be a lot of repulsions. It will not be able to hold that electron. So actually, the electron affinity of Cl is more than F. Okay, the electron affinity of Cl is more than F. So this is the wrong answer. Next, B option, first ionization energy order of aluminium. Okay, so we will have to write their electronic configurations in this case. So for aluminium, we know it is 1s2, 2s2, 2p6, 3s2, 3p1. And in case of magnesium, it is going to be, see, all of this same, it is going to be 3s2. So from here only we have determined that the ionization energy of magnesium is going to be more than that of aluminium, but here it has been written that aluminium has more ionization energy than magnesium. Therefore, the statement is also wrong. The atomic radius in case of this nitrogen family. So how is the nitrogen family? Nitrogen, phosphorus, arsenic. We know that on going down the group, size actually increases. All right. So, but it says that the atomic radius of nitrogen is the biggest, which is absolutely incorrect. Therefore, this should be the correct answer. And if I have to explain this option also, I will tell you how. So we have K plus Ca plus 2 and Mg plus 2. Okay, we know that this belongs to group 1, these belong to group 2. All right, so obviously, but then this size will have more size. All right, and also we know that Mg plus 2, Ca plus 2, we know that on going down the group, the size increases. So that's how the option D is going to be the correct answer. All right, option D is going to be the correct answer. This is how I have explained all the 4 options. There should not be any problem. Yes, most of you have said D, D, D. PK has also explained the order for the electron affinity. Yes, yes, that is the correct order. Yes, all of you are saying D. You are absolutely correct. Aryan, Temporary, Mehnas, Sumitra, Prabhat, Polemy, Manoj. Yes, Neha. All of you are correct. So let us move on to the next question for today. See, over here now we have the next question. This question says, the size of the d orbitals in silicon, phosphorus, sulfur and chlorine follows the order. So these are actually an absolutely correct order. Silicon, phosphorus, sulfur, chlorine. We know that as we go from left to right, the atomic size, what happens to the atomic size? The atomic size decreases. The atomic size decreases due to increase in Z effective. Due to the increase in Z effective, the atomic size decreases. So when we go from left to right, what happens? The size decreases. So since the size is decreasing, the size of the d orbital is also going to decrease. So the correct answer for this question is going to be option number D. This was a very simple question. Yes, Prabhat, it increases down the group and across a period it decreases. Everybody is saying D. Yes, all of you are correct. This was a very easy question. Now we will move on to the next question. The electronegativity difference is the highest for the pair. What according to you should be the answer? Please let me know. Write down the answer to this question in the chat. What should be the answer? The electronegativity difference. I'm sorry. Okay, the question is not completely visible. The question is not visible. I'm going to write the question here. The D option is lithium fluorine. You have to tell the electronegativity difference which is highest for which of the following pairs. All right. I have written the D option since it is not clearly visible. Yes, PK, I have written the last option. Everybody is saying D, D, D. Okay, Prabhat, last लिख दिया है मैंने. Surya, if you do not know the answer, I am about to explain. You will get to know. Mehnas says D option. Surya says A. Archana, I will read out the complete question for you. The question is, the electronegativity differences is the highest for which of the following? For which of the following pairs? Now everybody is saying D. No. So Let's see what should be the answer. Here, the correct answer is going to be option B, because we know that out of all of these, if I compare, let me compare all the cations. Let me compare all of the cations. See, the cations here are lithium, potassium, and sodium. All right, these are the cations: lithium, sodium, and potassium. All right. So when we go down the group, the size increases and the electronegativity decreases. Now, since the electronegativity decreases, so I can say that K has least electronegativity. Okay, K is actually least electronegative, and if I compare the cation anions, which are F and Cl, we know that F is actually the most electronegative element in the periodic table. It is the most electronegative. So therefore, in this case, K and F is the pair which have the highest electronegativity difference between them. All right. 𝗶𝗲𝗍𝗶 says K is the most electropositive and F is most electronegative. Yes, out of all of these options, K is going to be most electropositive and F most electronegative. Ayushi, yes. मनोज पूछ रहे हैं मैम ग्रुप में इलेक्ट्रोपॉजिटिव का ट्रेंड क्या होता है? Manoj, do you know what is the trend for electronegative? If you know the trend for electronegative, which is very, very simple, uska opposite trend, the exact opposite of that is going to be the trend for electropositivity. If you know the trend for electronegativity in any particular period or group, then you can very easily determine the trend for electropositivity, because it is going to be exactly opposite of that only. Okay, Manoj, I think it should be clear. ए के केमिस्ट्री मैम अगर ए बी सी डी को कंपेयर करना हो तो ए के केमिस्ट्री आई डोंट अंडरस्टैंड व्हाट यू मीन हियर. All right, I didn't get your question. So I hope this is clear to everybody. This is how we do these questions. We will determine which is going to be the most electronegative, and we will see which is going to be the least electronegative, and that's how we do questions like these. Now I will move on to the next question. The correct order of decreasing electronegativity of the following atoms is. So here, doing questions like these can get a little confusing. These questions are from different groups and different periods. All of these elements are from absolutely different groups and periods. So the best way to go about doing these kind of questions is, first of all, you write down where they belong in the periodic table, and then you can easily compare. So that is exactly what I'm going to do. I will be writing down their periods and groups, and after that I will draw comparisons between them. So let's see how can we do that. I see, first of all, I see an element of group 2. All right, I can see calcium from group 2, so I will write down group 2 first of all. Before I do anything else, I'm going to write down group 2. So I will give the heading group. So group 2, beryllium, magnesium, calcium, strontium, barium. So this is group 2. Now I can see elements from the nitrogen family, the oxygen family, and the boron family. So I will write down that too. See, for group 13, it is going to be boron, aluminium, gallium, indium, and thallium. All right. For carbon family also I'll write germanium, tin, and lead. Over here in group 15 we have nitrogen, phosphorus, arsenic, antimony and bismuth. Now that I have written, okay, one more is left, sulfur. So I will also have to write on the oxygen family, all right? Oxygen, sulfur, selenium, titanium and polonium. So now that I have written these, I will first encircle the ones. See, this is calcium, all right. Then we have arsenic also. Then we have aluminium. And what else is left out of these? What is left out of these is sulfur. Now we know that on going from left to right, the electronegativity increases, and on going down, we know that the electronegativity decreases. So we will apply this trend here and we will easily do this question. Okay, yes, Mehnaz, it's tellurium actually. Thank you for the correction. Thanks a lot, Mehnaz. Okay. So we will compare these. We know that on going from left to right, the electronegativity increases. So we know that the maximum electronegativity over here is going to be for sulfur. Sulfur will have the maximum electron negativity because it is the most towards the right. After that, it is going to be arsenic, As. Okay, after that, it is going to be aluminium, and in the end, it is going to be calcium. It took me time to write down all of this because I had to explain to all of you. If you remember all of these orders, you can quickly, very quickly, it will take hardly 30 seconds for you to write it down in the exam. You can quickly write it down and you can solve the question. And this is actually very easy. These are the questions that people tend to actually do incorrectly because they get confused at which element lies in which period. But if you write them down like this, if you gather them in one place, you encircle the ones which have been given in the questions and try to arrange them using very simple trends. How simple is this, right? How simple is this? See, we know that when we go from left to right, the electronegativity increases. Obviously it will increase, right? Because the Z effective is increasing, so the size is going to decrease, therefore the electronegativity increases. And I'm going from top to bottom, that is on going down the group, we know that electronegativity decreases because the size will increase. So that's how we get the trend. Just encircle the given elements in the table that you've drawn and quickly arrange them in the order of the electronegativity or whatever order that you've been asked in the exam. Mayank Kamboj, hello कह रहे हैं. Mayank, I feel it is too late for you to say hello when the class is almost about to get over. It is 1:48. We have Chem English sessions from 1 to 2 p.m. every day. The class is almost about to get over and you're saying hello. But okay, hello, you can still watch the lecture later on. That's completely all right. Mayank Kamboj, yes, this is absolutely used for JEE. The kind of questions we get in JAM and in JEE are almost similar in periodic table. So yes, this is very useful for JEE and you should absolutely watch the lecture. Okay, so I think it is very clear to everybody. AK Chemistry says that aluminium arsenic में confusion है. Aluminium arsenic में क्या confusion है आपको? I don't think there should be any confusions in aluminium and arsenic AK chemistry. It is very simple. See, arsenic lies towards the right of the periodic table. So it is going to come here only. What is there to be confused about? Yeah, this is going to be the correct answer. Option D will be correct. Okay, it is lying towards the right of the periodic table, so it will have more electronegativity. Now, this question is done. I will move on to the next question now. सूर्य मैम पीरियोडिक टेबल कैसे याद करेंगे? सूर्य जैसे periodic table learn karna is not very difficult. There are certain mnemonics available on the internet. You can go and check out those mnemonics. So when you remember those periodic table, the groups and periods using those mnemonics, then it becomes very easy. Okay. See, I will tell you the mnemonics that I use. Oh, Mehnaz says actually I have picked the incorrect answer. Yes, it is going to be option B, but I had explained the right thing. Okay, thank you, Mehnaz. Yes, B is correct. You are all right. I had explained the right thing, but I had by mistake picked option D. So I was talking about mnemonics, right? I was talking about mnemonics. So see, for example, I will give you an example. The mnemonics that I have made. This is just an example. Please, everybody, don't laugh at me. You can make similar funny mnemonics for all of you. It becomes pretty easy when you memorize these with the help of mnemonics. So what I have made for this is बेटा मांगे कार स्कूटर बाप राजी. यहाँ पे नीचे RA भी आता है. So this is how I have memorized it. All right. So similarly, I have made mnemonics for all of them. You can check them out on the internet and you will be able to find some, and that's how you can easily remember. So I will move on to the next question now. See, this question says the correct sizes of S2 negative, S2 positive, and S4 positive species is. We have to arrange them in the correct order of their size. See, we know that. See, we can say that size is directly proportional to negative charge. Size is directly proportional to negative charge, and it is inversely proportional to positive charge. All right. Size is directly proportional to negative charge and inversely proportional to positive charge. We see that out of these, if I have to arrange, see which one has the most negative charge. S2 negative has the most negative charge. Then will come S, then 2 plus and 4 plus. Plus 2 will come first, and in the end will come the most positive. That is S4. So this is the correct order, and the correct answer is going to be the C part. Okay. That's how we do this question. Option C, yes, everybody is seeing C. Mehnaz is writing down Mehnaz has written down the mnemonics for group 13. Yes, Mehnaz, that is a way of memorizing group 13. So actually these mnemonics are very useful, and all of you can use and memorize all of these. Yes, Neha, Malia, very good. Yes, you can also say that the size of an ion is greater than the size of atom, and in the end comes the size of cation. The more there will be a positive charge on the atom or on an atom, more will the smaller will it be its size. Okay, more the negative charge, more is going to be the size. More the positive charge, lesser is going to be the size. So I will move on to the next question now. See, the series with correct order of decreasing ionic size is. Again, just simply arrange them on the basis of their size. So check out which of these has the highest negative charge. So first is going to come S2. Then out of these, which one has then the maximum negative charge? Then Cl. Then out of these, C2 positive has the most positive charge, so it is going to come in the end. Then we will have K positive, and in the end we will have Ca plus 2. So which is the correct answer? I can see B option is the correct answer. Okay, so that's how we do questions like these. Just simply arrange them on the basis of the charge that is present on it. Okay. So it was very easy. Moving on to the next question. All of you, have you liked the video yet? If you haven't done that, please go and like the video, share the session with your friends, subscribe to our channel. Okay. Let's see. In this question, the correct order of the second ionization potential of carbon, nitrogen, oxygen, and fluorine is. I will first write down their electronic configuration, and then we will see which of these will have the correct order of second ionization potential. So let me write it down. For carbon, we have carbon 1s2, 2s2, 2p2. For nitrogen, we have 1s2, 2s2, 2p3. For oxygen, we have 1s2, 2s2, and 2p4. And for fluorine, we have 1s2, 2s2, and 2p5. So, after the first ionization potential, it will become 2p1. After IE1, it will become 2p2. After IE1, all right, this will become 2p3 after the first ionization energy, and it will become 2p4 after the first ionization energy. Now, if I have to determine which of these will have the highest value of the second ionization potential, now we will see which of these will have the maximum value of the second ionization energy. All right, now check. This is 2p1. It will very easily lose the electron and become 2p0. Okay. Now, this is 2p2. All right. This will also become easily 2p1. But see, this is half-filled configuration now. After first ionization energy, it is half-filled now. So it will be most difficult to remove another electron from 2p3 because of its half-filled nature. So to become 2p2, it will have the maximum ionization energy. So oxygen will come first. Then over here, we have to see this and this. After oxygen, see, after oxygen, oh, this is, sorry. So after this, after oxygen will come fluorine, 2p3. All right. Then there will come nitrogen, and then there will come carbon. So this is how we do this question. Okay. We found out that it will be most difficult for oxygen. So therefore it will have the maximum value of the second ionization potential. Then we will have fluorine, then we will have nitrogen, and then we will have carbon. See, carbon will have the least value. You see why carbon will have the least value? It will have the least value because it will easily lose this electron. It will easily lose this electron in order to attain noble gas configuration. It will easily lose this electron to get noble gas configuration. So oxygen will come first and carbon will come in the end. Okay. I hope everybody got it, and C option is going to be the correct answer in this case. Vishwajit, no, D will not be the correct answer. Prabhat, no, D is not the correct answer. I have explained to you, since we are talking about the second ionization potential here, so before the second electron is being removed, oxygen actually has a half-filled configuration. So when it has a half-filled configuration, it is very difficult to remove an electron from it, right? So therefore, C option is going to be the correct answer. The element with the highest first ionization potential, we just now we wrote down the electronic configurations of all of these following. We know that nitrogen has half-filled configuration. We know that nitrogen has half-filled configuration. So it will be very difficult to take out an electron from it. So it will have a very high ionization potential. Therefore, nitrogen is the correct answer. Gautam, ma'am, can you teach topic? Gautam, right now, the 1 to 2 p.m. class that we usually have is for the previous year questions in this Chem English session. I will try to teach you some of the important concepts from the periodic properties chapter in the next class. Okay, I will try to teach you the important things from periodic properties in the next class. Okay. No, D is not going to be the correct answer. C is going to be the correct answer in this question. So that is all for today. This was the last question. Thank you very much, all of you, for joining today's session. Before you go, please like this video, subscribe to our channel, and also hit that bell icon so that every time we upload a new video, you will get notified and you will be able to watch the sessions live. Okay, everybody, thank you so much for joining today's session. I hope everybody enjoyed today's session. Yes, Keshav, the classes happen every day. Okay, the thumbnails get uploaded. The thumbnails get uploaded on one day before, so you can check out the thumbnails and you will be able to know what all classes are going to happen on the next day. Thank you everybody for joining in today. All of you stay safe and have a great day. Bye bye everyone. I'm going to end the class now.